Right. Good morning. Nope, not yet.
Good morning.
Morning. Hold on. One more joining.
Good morning.
Morning. Let's see. Laura's joining, but it's taking her a while.
Miss Vibes, I got a question.
Yes, ma'am.
So, on the discussion boards, because I think discussion board 5 and 6, they don't have a due date. Do we supposed to do those?
Yes.
Okay. Okay.
Yes, you're supposed to do all of them. They don't have a due date. I haven't put one on
Uh-uh.
there. Okay, that's probably because we haven't gotten there.
Okay. Yeah, we haven't.
Yeah. But let
Okay.
me see. Let me see. Because they were supposed to all have a due date of December 10th by now. I don't know what is going on. I had done all of that.
It's showing that they late August something, it say.
That's because it didn't change. I had done all of that, and for some reason, I had to redo it. I mean, I had to redo it for every class, and I guess I forgot yours, but I had to redo for all of the onlines, which are more important because they're online, And it said 1,000. It said 1,900. Can you believe this? Like I would have put it in 1900. That's crazy. The online people go a little faster than we do, Well, it depends on who they are, but most of them do. And they were already finished with their 4 by now, so with the topic 4. So let me go ahead and edit my settings, at least on the 5, just to make sure that we have it open. Okay, availability. Yep, it does say August. You're right. Okay. It's supposed to say December 10th.
Okay,
Hey,
so it's all of the discussion boards that we see.
yes,
Okay.
every one of them is open until December 10th, and I'm just going to do that later. But right now, I'm just putting that one, so we'll have it. Save and return. Come on, baby. Let's go. Let's go. It's not going. Oh, there it goes. Okay. All right. So let's see. Everybody joined by now? Is Laura already on there? Nope, she disappeared. Uh-huh. That's what I thought. Because I never heard her come in. Normally, you hear beep beep, and I know that you're coming in, and I let you in, and she never came in completely. Okay. Well, anyway, so okay, so we are actually starting on that topic, the atoms, ions, and the periodic table. So the very first thing we're going to do is look at this PowerPoint
So,
called, yes, ma'am?
look, I had problems on that. You remember when me, you and Lori was going in and trying to put that little 3 square thing,
I
and
told you it would be hard.
it would not let me do it, and it kept
Mhm.
making me getting it wrong. Like it would not put the third square for some reason.
Okay, let me,
Like where you put like the symbol,
yeah,
it wouldn't let me put the symbol. It'll let me put the two numbers, the protons and the
okay, let me see if we can go there and get it. Look at it. I mean, not get it. Up there she is. I think she came back. Yeah, there she is. I admitted her again. Oh, that time she made it. Okay. See, can you hear those little ding ding or no? Or is it just me?
yeah, we can hear them when they come in.
Okay, so you do hear it. Okay, so that second ding ding means she's in. Because right now I'm not looking at you guys. I'm just looking for that one connect thing so that we can go look at it. Okay, so do you
Lori,
still
could
have
you answer that question correctly when we did it together, with the little 3 boxes?
time? I mean, do you still have
Yeah,
it?
I still have an attempt. Yeah,
Okay.
I just
Okay. Let me it was on chapter 2 application, right?
yeah, chapter 2 application. I think it's problem number 2.
Okay, and yours and everybody's is not. It's just it's weird. I mean, mine and so far mine has been all over the place when I show the students this. So let me see what it when it is. Okay, this is not it. Okay, let's go. Oh, I was gonna share once I got there, but I'll just go ahead and share now. Not this though. I don't want to share that. Mm-mm. Okay, there we go. Share screen. Okay, come on. Mhm. So I'm sharing a lot of stuff right now, but there it is. That's the Zoom that you were, I mean the Connect that you were looking for. Yeah, not that one. Let's see. Not that one. Not that one. Not that one. Oh, that was it. See, they don't always come out for me. So this one right here, what you need to do with this one is just put O2 negative. So that would be this one. So you put the capital O, right? Remember, it's got to be capital. And then you use this guy and put the -2. And always negative first because they like to know that it's a charge.
So I was trying to use the third box with the 3 boxes, but it
Not for
won't.
this one, not for this one.
Yeah, not for that one, but for the question that I kept, it would not let the
Yeah,
third box pop
let me
up.
see
And
if
so it let me get the first, the 2 boxes correct, but the
uh-huh.
third box, it kept making it like a little small box. It wouldn't make it a big box.
Okay, let's see if this is what they wanted. See, incorrect. Okay. Okay, I am crazy. That's because it's always been that. Nope, this is definitely not the right answer.
So it just want the symbol, I think. Just
No, I
O.
know, but it's sulfur. I just realized
Oh.
I'm doing the wrong one. Yeah, because it's always been oxygen every time I've done it. So now it's sulfur. See, I told you you can't just think you've got it when you don't have it. All right, now it should be correct. There you go. So see, it just wanted that in this one. Okay, I don't know. Because none of these had that. See, none of these have that. It's not getting us to do the, oh yeah, here. There we go. This one does. Okay, so we want to do the symbol on that one, right?
You want to have like the 3 box one where you got to put the
Yeah, on
proton.
this one.
Yeah.
Yeah, okay. So let's complete this whole table and then we'll check, make sure it works. All right,
Okay.
number of protons, 11, neutrons, 12. Number of electrons, 11. Okay, this one, electrons, 9, and electrons, and this one's 6. Where are you? This one is 12. And 12 here and 12 there too. No, this is 11 actually.
How do you do that so fast?
Oh, practice.
Lori, was you able to do this? Was you able to do like the little 3 box?
I haven't even tried yet.
Okay,
Oh.
so this is where
When is this due? Is this due before midterm,
gonna
or is
do,
this
okay,
midterm, or is this
so
after midterm?
watch, it's after, no problem. So let's look at this.
Okay,
So
okay.
this is fluorine, right? Because it's 9. So we're gonna go ahead and click this first, okay? So then let's see, the 9 to grab, I can't see now. 10 and 9. So 19 goes on top, and then the 9 goes on the bottom. And then you just hit space. I mean, like enter, right? And then click it. Oops, nope, you're not doing that. Okay, enter. And then you can just supposedly put the fluorine there. Oh, it's not letting me. Oh, wait. Why are you not letting me?
It wouldn't let me.
I see that. Okay, maybe we did it wrong. Let me clear it all. Maybe we need to put the fluorine in first and then hit this thing. Nope, that's backwards. Okay, nope. Okay, let me think. All right. Okay, click this guy. Yeah, okay, that would be 19 and 9. Then you put a space, not a space, but it's an enter. Oh, I know. That's what it is. You need to use the arrow that goes forward and put an F. Yeah, see? There, that worked.
Okay.
Well, you can't see what I did, but the
Yeah,
arrow,
press the arrow on your keyboard.
or this, yeah, or this one. If you
Okay.
have one, you can use this one. Hold on. I'm saying this
Okay.
one, and I'm highlighting it, but I can't highlight it because I don't have the spotlight on. This one right here, you can use that one too.
Okay.
Okay, so let's see this one. This one would be, who is 6? That would be carbon, isn't it? Yeah, that is carbon. Okay. So let's click on it. All right. And then get the little guy, this guy. So it's 6 and 14, right? Oops, sorry, 14 first, and then 6, and then 6, and then this arrow. See, you can use this arrow and put that.
Oh, okay.
See, it worked.
Mm-hmm. It
Okay.
did work.
Okay, so
Okay, I
let's
kept trying and trying, and I was like,
there.
okay.
Okay. Well, you know, this is why we talk together and figure it out together, because sometimes it's a little different for everybody. Oh, sorry, Sam. I did not let her in. Okay, so there. So that's kind of how you would do it. Okay. You just do it, put in, okay, so click. Once you click, you put in that that sign with the 3, put the top, the bottom, and then hit the arrow and put the capital, you know, the symbol.
The symbol.
Yeah.
Okay, thank you.
You're welcome. Hopefully that'll do it for you. All right. No problem. Let's see. Okay, let's stop sharing this. Well, actually, I don't have to stop sharing anything because I'm already here. All right, so let's go to the next thing that we're doing. I forget that the spotlight also allows you to move, which is good because it used to not. And it was annoying. I had to stop the spotlight, then go back to the mouse, and then keep going. But this one is both. So, okay. We did that already. Oh, man. Okay. So we did all of this already. We did that. That is all done, except we said next we were going to look at periodicity. And that is this PowerPoint right here. Periodicity is actually a very simple concept. It's just a lot of people get confused. Okay, so did it come up or not? Yeah, there it is. Get confused only because the arrows, the way that the trends go, was one of them is backwards from the other. So it's when people get confused with it. Okay, where is my PowerPoint? Come on, open up. Maybe it won't open up with the spotlight. I don't know. Yeah, it did. Okay. So we are going to start not with electron configurations because I like to usually not talk about those yet. Just talk about this part first. Okay. So the periodic table, you know, Dmitry Mendeleev is the father of the periodic table, and he was the first one that figured out how to organize them. So he did, and he did a really good filing system. It actually is logical, and you know, he had columns and that were similar. So he didn't do rows and all that yet, but he knew that there were some elements that hadn't even been discovered yet, but he left blanks for them. And when they were discovered, they fit perfectly in there. So, you know, he was pretty smart. But the only thing is, since it was in the mid 1900s, the neutron had not been discovered. Therefore, he used atomic mass because they didn't know there were isotopes yet. And that's when the problem came in, you know. And so this other guy named Henry Moseley said, okay, so now we know more, and look how much later this was. Okay, See, he did it by atomic number. He did it much later. Once everything had been discovered, this is what we have now, is this modern periodic table, which increases the atomic number from left to right and top to bottom. And as we know, this is what makes this happen, this phenomenon, which is called periodic law, which means that the elements are arranged in certain order. And so there is a tendency that is seen in their physical and chemical properties because of that. All right, so we know these names, but they are all here. So if you ever want to find them, here they are. They're all right there. Every single one, except for the last two, which are, lanthanides and actinides, but down here. But these, they're all right there, every single name. All right, so now let's keep going. And okay, so there are certain properties that you can actually see how well they go with this periodic table. And of course, as it is, it's a trend. It is not a perfection thing, right? They don't all follow that. There's some exceptions, of course, but you can pretty much predict everything. And when we are doing this, they will ask you to use nothing but the periodic table to predict. So do not go looking for the numbers and put them in the right order. Use the trend, okay? So these are 5 properties that we're going to look at: atomic radius, electron affinity, electronegativity, ionization energy, and ionic size. Let's start with atomic radius. So remember how we always talk about the electron cloud being so hard to measure and hard to figure? Okay, well, that is true. Since it is such a weird little fuzzy boundary, we have a method. What they do is they bond atoms of 2 identical atoms and then divide that distance, which the nucleus is easy to find, divided by 2. And then you've got your radius. When we're looking at the periodic table, there's an decrease in size as we go right. Okay, so basically as we're going, like you read a book, right? As you go right, they are going to decrease in atomic size, which is interesting. But now this part right here, it'll not make sense yet, but it's okay. Elements are added to the sublevels in the same energy level. That part makes sense. And they are gradually pulled closer to the highly positive nucleus. That is actually known as electron shielding. And here's the actual, see how the trend is actually pretty good, except for these down here. These down here don't work very well. But see, the trend is very good right here. I mean, you can see that it's definitely decreasing as you go across to the right, and increasing, of course. And I always try to remember just one trend, either increase or decrease. So if you want to remember increase, then this is the way, right? You going right to left and top to bottom. And if you think about it, each time that you go down, you're adding one more level, right? So it's like an onion. If you add one more level, it gets bigger. If you take one away, it gets smaller. So that makes sense. And then going across doesn't make sense as much until you think about what's going on. What actually is happening is you are putting all these electrons, which are negative, right, into that area. But you're also adding protons, which are positive. So they're going to attract the middle. The middle is going to attract the electrons towards itself, the more electrons there are. And the more electrons there are, the closer they're going to get, because then you got the positive negative balance. Now, there's also a problem where you've got all these repulsions going on between electrons. So that is another reason why they have enough volume. See, the same volume is there. So if there's enough volume and there's less electrons, they become bigger because they're repelling also. Whereas when they get too cramped, they can't really move. all right? But they can get closer to the nucleus, which is what happens, all right? So that, like I said, that is known as electron shielding. And if you look at a diagram of atomic radius or a graph versus the atomic mass, you can see that they're exactly the opposite. And as you would expect, all of the alkali metals would be at the top because they're all on the left, and they would be, you would be correct. And then the bottom ones would be all the halogens. And halogens and also the what do you call them? The sorry, noble gases.
Metalloids?
Yeah, noble gases.
Oh,
Also.
noble
Yeah.
gases.
Yeah. So
Oh, I see
okay.
now.
So that was, yeah, that was your beginning. Okay, so now let's keep going. Now we have the atomic ions, right? The ions that are made. Remember, metals make positive ions and non-metals make negative ions. So it stands to reason that when you lose electrons, right, you are losing a whole layer, right? So of course you're going to get smaller if you become positive. It makes sense. Now, for some reason, this is not advancing. There we go. Why? There we go. Oh, there we go. All right, it loses a layer. See, that's what I was saying. Okay, so then the negative ones gain, but they don't gain a layer. They just gain electrons. But remember what we talked about, that beautiful balance that was there before? The protons and the electrons were perfectly balanced 1 to 1. Well, when you add 1, you are causing that extra repelling of the electrons by each other, because now you have more electrons and less protons. Therefore, it gets bigger. You notice it's almost twice as big if you look over here. So it does get quite bigger. All right. So here's the trend. If you look at it, it's actually pretty much what we said. Now, one thing to notice is the more electrons you lose, you see this? These two right here, the smaller you get. Because the ions, the negative ions don't do that, but the transition metals do that. And the more electrons you lose, the smaller the atom, the ion in this case, sorry, gets. And also look at sodium and magnesium. See, they're also smaller, but they started off as smaller also. So remember that trend. Okay. All right. All right. So now the next one. Okay, this is, we're not looking at that. Nope, 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 nope. That's coming, but not yet. We're not looking at these yet. All right, so the other periodic trend is ionization energy, which is also known as potential. And basically what it is the energy needed to remove an electron from an atom, okay? And of course, we're talking about valence electrons because the middle electrons are not going to happen. So, you know how many there are based on the periodic table. Okay, so another way to look at it is how strongly an atom holds on to its outermost electrons, okay? So if they're held strongly, then you will have a high ionization energy. And look at who has the highest. And it makes sense that all of these guys would not want to give up one single electron. They're all noble gases. The reason they are all the highest is because they're already full. Remember, they have their 8 electrons and they're happy. They don't want to let them go. And the more electrons you have, the more likely you are to let go. So obviously helium would be the one that you would want to let go least. So then this trend increases from left to right and bottom to top, not top to bottom, but bottom to top. So see, it's exactly backwards from the other one. So you got to make a note. You either remember this one or remember the other one, and remember that all the others are backwards, So that's kind of how it works. So if you remember this trend, then all the others that are coming are the same. But if you remember the other trend, then every one of them is backwards from this one. So basically one or the other. And there's the ionization energy. If you look at it, there's the map, there's all of the actual numbers on there. And as you can see, it does. See, this magnesium doesn't quite follow, but don't worry about it. I mean, it does follow, but aluminum, sorry, doesn't quite follow. But that's okay. Don't worry about that one. It's a trend. Trends mean there's some exceptions, right? Always. And here, phosphorus and sulfur also. Just like I said, do not worry about that part. It's the trend that we're looking at, nothing but. So if you go looking for the actual numbers, the trend is not going to work. All right, so the ionization energy is generally measured 1 electron at a time. And this is what I was telling you also, that if you lose more electrons, you're going to need more energy, because you're going to need to remove, like, look, sodium you only remove 1 because it's in group 1, but then the core electrons, they're impossible to remove, too much energy. It's 10 times greater almost. And then magnesium, you remove the first one, and the second one's a little bit harder to remove. But look at the core. The core is really a lot more energy, almost 10 times again, well, more than 10 times that of the first one, and so on and so forth. So if you look at each time, the more electrons you remove, the harder it is to do so. But once you get to the core, that's not happening. And see, this is why the noble gases don't want to let go, because look at how much energy it takes to just remove the one. It's almost the same amount as this right here, which is the core, right? So we don't really make ions with noble gases. All right. So let's look at this next trend. Okay, no, not next trend, but this thing, which is ionization energy. See, there is not enough energy to produce an Na2 plus ion to make this compound. So whenever you make compounds, they have to be, how they would naturally occur. And that would be with the least amount of energy spent. So you have to follow the rules on the periodic table as to the group where they are and which ions they make. Because magnesium is in group 2, so it would never make a 3. And aluminum is in group 3, so it would never make a 4, right? All right. So another periodic trend is known as electron affinity. Now, pay attention to the definition, because this definition, you're going to see it again, except with a few more words coming up. So a measure of the ability of an atom to attract or gain an electron. That's all it is. So how likely are you to make a negative ion? And if you think about this, who makes negative ions? The nonmetals. So all of the nonmetals are to the right of the periodic table. Therefore, this trend again increases to the right, and the less electrons you have, the more likely you are to attract one. Therefore, it also increases to the top. So here it is. And you would be correct if you expect, and this particular trend does not include the noble gases. As you can see, they're down here. And that's because who wants to get another electron if you already have enough, right? Nobody does, so they don't. But fluorine, chlorine, bromine, iodine, and astatine are all at the top. And that's because they are the highest electron affinity. They are in group 7. They already only missing one little electron to make, 8. So they are going to look for them, especially fluorine and chlorine, which are the 2 highest. And you notice that fluorine beats chlorine in this case, but don't worry about that again. You do not want to know that. You're just looking at the trend. All right, so the octet rule is that fulfillment of electrons. Basically, you're either going to gain or lose electrons or share them based on, depending on which bond you're making, in order to acquire a full set of valence electrons, which a full set is 8. All right. And here's a Bohr model representation of all of the atoms and their ions, atom and their ion. And you notice they're trying to show you that they all look like this neon, not the inside part, right? Not the nucleus, just the outer area of the electrons. So the electron cloud mimics that of the neon. Sodium too. Sodium loses 1 electron and now it becomes just like neon. And so does magnesium losing 2. See? So that's kind of how that works. All right, so we're skipping this for now. Okay, so electronegativity is a key trend. Remember, I told you to remember that one definition. Look at it. It's the same definition, except in this case, it's in a chemical bond. And this is very important for us because when we're making compounds, we are going to be looking at what kind of bonds they make based on electronegativity differences. So it is important to know which one is most electronegative, and that would be fluorine. And remember, if you are going towards fluorine, and you notice this one says decreases as you move away. Okay, so we are going to always increase. So again, it increases from left to right and bottom to top. Okay. So these are the 5, and see, there's the electronegativities. And as you can see, they pretty much follow that trend. Lithium being the lowest, then you've got beryllium, then boron, carbon, nitrogen, oxygen, and fluorine. Some of these aren't exactly perfect, but you know what? Nothing is perfect when it comes to trends. So just remember that the trend itself is telling you that it would be how it was. All right, so here's a kind of like a view of the last arrows that we're talking about. And now let's go practice, because practice makes perfect. Now, boiling and melting point is interesting, but it is not the way you would expect it. So we are not going to talk about that one. And metallic character, yes, because metallic character means you're losing electrons. So of course, you're going to be more likely to lose electrons the farther over to the left you are, right? Because you only have one electron on the outer shell. And then this one has 2, so it's less likely. And then these have 3, so even less likely, and so on and so forth. Okay. And then the non-metallic character, which means to gain electrons, you're going to be increased towards the left, the right. And that
Increase electrons, you mean?
No, increase the non-metallic character. It would increase towards the right because
I see.
the more, these only have 7, so they're going to be looking for the 8th one really strongly. And the less electrons you have, the more strongly you look for them. So obviously fluorine is going to be looking for it the most. Right.
So this periodic table is basically when you gave us that blank periodic table and we wrote it in?
Yes.
Okay.
Yes. Okay, so that's it. That's good enough for that. Okay, so let's go practice now. Let me see if I can get rid of this guy without getting rid of everything that we've done. Yeah. All right, so we're doing the periodic table trends practice. Okay, so with this one, basically what we're going to do is we're just going to look at the elements, find them in the periodic table, look at which trend they're asking for, and put them in order of increasing or decreasing, whatever they're saying increasing, so increasing ionization energy. So you notice that the word here, the key word is increasing ionization energy, right? So we have to keep that in mind, right? Okay, and look at these. All right, so looking at the periodic table, you will see that the most, okay, so remember the trend, and I'm just going to write that up here, just so that you remember the trend. The trend goes from like this, right? That's the trend. Okay, so we're looking at bromine, krypton, calcium, and arsenic. Calcium's going to be the least because it's the farthest to the right. I mean, so they're the left. I'm backwards today, so if I say right, I mean left. I don't know what's going on sometimes. All right, so we're going to get, nope, I need this. Okay, so we're going to put here calcium. That would be the least. Oops, the least. So let's do it like that. All right, then keep going on the periodic table and look at,
Is arsenic the highest?
no, arsenic is not. You notice that we have arsenic next. Then we would have, see how
Where's krypton?
keep looking at that same level 4. So calcium is all the way to the left, across, and you see arsenic next, right?
Okay.
And after that, you see,
Oh, krypton is the highest.
yes.
Okay,
Then
I
you
see it at the end.
selenium, then you see bromine. So
Krypton,
bromine is
yeah.
next. You see that?
Bromine and then
Mhm,
krypton. Okay,
correct.
I got
See
you.
how easy that is?
Mm-hmm.
It's just looking at the trend, but keeping this in mind, right? This is the main
Right.
thing. All right, so you
Okay.
do the next one. Who's
Okay.
the least ones of these?
I'm trying to find them.
They're all the noble gases. Every one of those is a noble gas. So they're all the way to 8A.
I know helium is the highest.
Yes, okay. So you know that part. Okay, so who's the lowest?
Wait, helium and xenon?
No,
Is
xenon.
xenon the highest? Because I
No,
mean,
no.
xenon come after helium
See
though.
how the trend goes? You see this right here?
Mm-hmm.
Okay, so it goes from bottom to top, increases. So the
Okay.
lowest is going to be at the very bottom, right?
So xenon is the lowest.
Radon.
Wait, I haven't found radon. Oh, radon is.
Yeah, radon's right below xenon. And then xenon, right?
Oh yes, radon. Oh, it's going up.
Yep,
Oh,
correct.
okay. Radon first,
Mm-hmm.
then xenon,
Mm-hmm.
then argon,
And you were right about the helium. See that?
and then helium.
Right.
Yeah.
Yeah. All right. So now this next one right here is let's see, that is
Okay, it's gonna
for
start
A.
with
Yeah, it's with 4A. So who's going to be first?
lead,
Mm-hmm. Correct.
and then you have germanium,
Germanium. Mm-hmm.
then you have silicon,
Mm-hmm.
and then you have carbon.
Correct.
Okay.
All right. And then this one has got krypton, arsenic, germanium, and selenium. All right. Krypton, arsenic. So that is period 4 again,
Okay.
but a different set of them. So
Right. Ooh.
yeah, I know. You just got to look at all of them and see
Arsenic.
where they are.
Okay, it's gonna start with
CS,
where's cilium?
CCM.
Okay, so you got
Because cilium and germanium is on the, okay, so it's gonna
yeah,
be germanium first,
germanium. Yes, correct.
then cilium,
Selenium.
selenium,
Mm-hmm.
then arsenic,
Okay.
and then krypton.
See? Okay. Next,
Okay, on that one, I'm confused. Why would arsenic go before,
look at the
why would
trend. Look
selenium
at
go
the
before
trend.
arsenic?
Look at the trend. I mean, low over here, high over here. So if you're going from
Right.
left to right, that's on the periodic table. That's exactly how they are. So you know, you got germanium, then you got,
Okay, no, it's geranium and then arsenic.
you're right. Oh,
Yes.
you're right. Oh, you're right. See, you're correct.
Okay.
It's good to pay attention.
I was like, hold on.
Yeah,
I'm just glad my voice is working on the thing today.
so that means it
Me
works.
too.
See, when you can do that, that means you're understanding it. See, that's what I love about this, is when somebody says, wait a minute, that's wrong. And I'm like, okay. And you're right. So, okay, next one. You got potassium, rubidium, cesium, and lithium. That's all group 1A. That's just to help you locate them faster.
Right there in order.
Yeah, exactly. So they're not in the right order.
No?
No. Who's at the very bottom?
Oh, well, you said it in the right order.
Potassium.
I said I'm in the right order. No, I just kind of read there. Potassium, rubidium, cesium, and lithium. Okay, so cesium first, right? Because we're going up.
Oh
So
yeah,
cesium would
cesium,
be rubidium.
rubidium.
Rubidium,
Then
potassium, lithium.
and then lithium. There you go. And then this last one is lead, germanium, carbon, and tin. Okay, that is a group also, and it is group 4A.
So then it would be
Lead,
lead,
There's lead is always at the bottom.
tin,
Then
germanium.
tin,
Uranium, and then carbon.
and this time, yes, it is correct. All right, so see, that's what you have to focus is pay attention to what they're asking for, then make your trend in your head, right? Or write it down if you need to, it's fine. And then answer the question. And that's how it's gonna go. All right, let me clear that one and go to the next one. All right, so the next trend, it says atomic radius. So now we gotta focus our energies in increasing atomic radius. Okay, so again, how does it increase? Okay, this is the one that's backwards. Remember, this is the one that goes this way, right? And down, right? That's how that one works. Okay, so now that we know that, let's go and do these. Now that you know what you're doing too, because you do know what you're doing. All right. So that one would be
krypton,
okay.
bromine, arsenic, calcium.
Okay, I want you to see something. Remember the elements from before? You see how they're exactly backwards? See these?
Right.
They're the same elements, well, but exactly they're backwards because the trend is opposite. You see that? So, but I'm not gonna let you see all of them because I want you to practice. All right, so the next one would be what?
Helium,
Mm-hmm.
argon, xenon,
Mm-hmm.
and radon.
Right. And there's the next one. We don't have to do all of them. If you feel comfortable already, we just skip it, but you can kind of feel it already or no? You're good? You think?
I'm good.
You're good? Okay, so like I said, we don't have to do them all of, I mean, it's obvious that they're exactly backwards from those, see? Again, yep. So let's do these. Okay, so now we're focusing on, let me erase that trend because that's the wrong trend now. All right, on increasing electronegativity. Oops, come here, you. Okay, so we're looking at, oh, come on, why are you not letting me highlight? There we go, increasing. It is not letting me highlight. Why are you not letting me highlight? There we go. Okay, so increasing electronegativity. What is the trend like? How does it go? Did you
To
write
the right and down.
to the right? Okay, so it increases from left to right, right? Like, oops, come here, you. It's not letting me write. Okay, left to right and down, you said, like this. No, it's not down. It's up. Okay, so that's the trend.
It's up.
Yep, up. Remember, fluorine happens to be the most electronegative. So it increases towards fluorine. If you think about it, that would be up and to the right. Okay, so these are not the same ones. These are totally different from the last set. So these are going to be the ones that we're doing. They are, okay, so we're going to, okay, so lowest would be the top, no, the
Astatine.
bottom one. So astatine, yeah. Yep, that sounds about right. Then it would be
Iodine,
iodine,
bromine, and chlorine.
bromine and chlorine. That's right. See? Same here. Okay, this time you have magnesium, phosphorus. So this looks like group 3. The lowest one is going to be
Magnesium,
magnesium. Yep.
and aluminum, silicon, then phosphorus.
Okay, perfect. And like you get the gist, right? Or do you want to do more?
I understand how to do this part. I just got
Okay.
confused on up and down and left and right.
Right, and that's what I was telling you. That's the key, is to remember your trends. Every trend is going to be exactly like this. Okay, so one that we haven't done yet is electron affinity, which this one is going to include noble gases. Or not. No, this one is not. The only one that includes the noble gases is that other one, which was ionization energy. Electron affinity is not going to include the noble gases because the noble gases want to gain. So basically, every trend that we have from now on, because we already did the one that is backwards, is going to be like this. Every one. Now, one of them includes the noble gases, and that is ionization energy. And it makes sense because they are least likely to make ions, right? So noble gases would be outside of this trend. Do you see that? So increasing electron affinity is the same sort of as the one we just did, pretty much, right? So,
Is it?
Yep.
It's not down.
Nope, it's up
I'm
again.
so confused. Up again.
All of them are up, yeah. See, that's the thing, is that they are up, definitely.
So then ionization energy is to the right and up. Increasing electronegativity is to the right and up. And increasing electron affinity is
to right
and up.
Yep. Except the one that you mentioned, ionization energy, that one does include the noble gases, whereas all these other ones do not. So remember that part too. Okay, so in this case, that would be astatine, right? Just like we did before. then
Yeah.
iodine. Nope, there's no iodine. Yeah, there's iodine. Then bromine, and then chlorine.
Okay.
Okay. So that's pretty easy. And then all the other ones are pretty much following the same thing. All right. So the next and last, this one is a little confusing. And the reason it's confusing is because, okay, so it says the larger of the two species. So we're going to highlight the larger. Okay, so we said that when lithium loses an electron, it also loses a layer. So the larger would be the lithium ion atom, not the ion. Chlorine and chloride ion, it would be the chloride ion because it imbalances, remember? That
What did you call it?
chloride ion. Yeah, it's always changes less the ending when it's negative ion. All right, now this is where people are like, well, which one? Well, do you remember the trend of how they increase in size? So increasing atomic size goes like that, right? So calcium is here, right? And potassium is here. So this one started off bigger. Therefore, it's still bigger, right? Does that make sense? And the other thing that I told you is the more electrons they lose, the smaller they get. And calcium lost 2 and potassium only lost 1. So obviously here, the same thing. See, aluminum is going to be right here. So aluminum is going to be the smaller one of the two between calcium and aluminum, right? I mean, magnesium, sorry, and aluminum, which is kind of where calcium is, aluminum and magnesium. Magnesium here, aluminum here. I should have done it there, but it's okay. It's still the same trend. All right, so aluminum would be the one. All right, so in this case, oops, come here, you. We're highlighting aluminum, and it also lost more electrons, as you can see. So now, copper and copper 2. See, which one lost more electrons? Obviously, copper 2, right? So copper 1 is going to be the larger one. Now, here is where it gets confusing. All right, so magnesium was bigger, right? Because magnesium's over here.
Wait a minute. I'm so confused.
If you look at
aluminum is bigger than magnesium?
No. Oh, sorry. No, I did that. I messed up. Sorry. Nope, it's not. You're right. Nope, you're not confused. I did that wrong. Let's take it away. Thank you. Goodbye. No, you're right. You're not confused. Do not become confused because of my messed up thing I just did. Sorry, I meant to put that one. I don't know why. I was talking about aluminum and so I highlighted it. All right, now.
So then, even though aluminum lost more, magnesium is still bigger?
Yes.
Okay.
Because it's always the larger of the two. Plus, magnesium was bigger to begin with because
yes.
You see how it, yeah, okay. So now magnesium or sulfur. Well, magnesium's there and sulfur is over here somewhere, right? Oh, sorry. My finger is not coloring because I don't have anything there. Sulfur is down there somewhere. Okay, so sulfur is smaller, but it gains, so it gets bigger. Magnesium is bigger, so it loses and it gets smaller. You're like, ooh, that's hard to do. Yep, it is. But remember when I always tell you, who does it look like? Which noble gas does it look like? Okay, this is where it all resides. If you're looking at magnesium, magnesium becomes like neon. So neon versus argon, because sulfur becomes like argon. So which one of those is larger?
Neon.
No,
argon.
Argon. So that means sulfur is larger. See, that's where it pays to know which ion they make, because you can actually tell that one becomes larger.
An ion means basically what it looks like, not what it turns into. I get so confused over
Right.
that.
Remember, it looks like, so basically neon has 10 electrons, right? Officially, right?
Yes.
Okay, so
Yes.
it's got 10 electrons. Arsenic has 18, right? Okay, when you add magnesium, which was 12, subtract 2, how many do you get? 10. See? They're called an isoelectric species because they have the same number of electrons. Argon, okay, sulfur has 16, but you're adding 2, so you get 18. You see that?
I see.
Those two look alike. That's what that means. Not the inside.
I see.
Obviously, the nucleus is still going to be, you know, however many protons and neutrons argon has. Argon has actually 18.
Okay.
Yeah, so
Okay, that's
that's not
making a lot
changing.
more sense now.
Yeah, that's not changing. The protons are still 18 for argon and 16 for sulfur, but the electrons are exactly the same. And so
Okay.
when you're looking at that, it also always is a good thing to kind of compare to which of these atoms it would look, you know, noble gases it would kind of resemble, because then you know the size also.
Okay.
Okay. All right. So that's basically it. So to recap of, and I meant to not do that. I meant to do this. All right, so let's share this one last one. Okay, so to recap, trends, and I'm gonna do one in red, some in red, and some in blue. So electron affinity, right? So this is EA. I'm just gonna call it that. Ionization energy, and this one includes noble gases. Yeah, I'm putting Ng there, so yeah, you remember that ionization energy includes the noble gases. Electronegativity, so En is what this one's called. All right. And then the last one that we need is
Atomic radius.
atomic radius. Yes.
And it's totally backwards.
Exactly backwards. You see that? So you can remember one or the other. You know, if you remember this one, remember that this one's backwards. If you remember this one, remember everybody else is backwards. And that ionization energy does include noble gases. Okay? That's the only one, because they will not make ions. So the mess up, see, if we'd included the noble gases in electronegativity, they would be really low, because they don't want to make any kind of bond, right? So that's why they're excluded from this trend. And if you do the same thing with electron affinity, same thing. They're not looking for more electrons. Therefore, the noble gases are not in there. So noble gases are outside of this spectrum, but they're included in this one. This is the only one that includes them. Okay. Of course, atomic radius has nothing to do with reactivity, so they are included there too. But I'm saying that the ones that are growing towards the noble gases, they're excluded on these two because of that reason. They do not want to make ions. They do not care to add any more. They do not want to bond. Nothing, right? So leave them alone. Basically, is what they're saying.
So then atomic radius, I mean, that also includes noble gases because it's
Yeah, because noble gases, it has nothing to,
okay.
yeah, it has nothing to do with bonding or electrons. It just has to
I
do with
see.
size, right? So that one does include the noble gases and everything else, because it's just a size thing. Okay. All right. So that's basically the whole lesson for today, right there in one big arrow. Just remember the arrows. And they will.
And you'll be posting this video later, correct?
Huh? Yes. Yes, I
You'll
will.
post this online?
Yes, I will.
Thank
I will. I'll post it later because I'm about to stop the video now because we don't need it anymore. All right, and stop the sharing because we're done with that. And we're done pretty much.
Okay, well, thank you so
So,
much.
you know, okay, so let's see. I need to, I already posted your grades, just so you know.
Thank
Because
you.
they were actually due yesterday. I gotten a little mixed up on that one. I kept saying this the 19th, and then I thought, but we're off the 19th. They're not gonna make us work on the 19th. So I checked the and the calendar said the 17th. So yeah, I was like, oh my God. Good thing I had been grading already.
Yes.
Because I had to grade all of those. Those are one of the hardest things to grade is the essay question, because I got to give you ideas of why it's wrong, right? So I put all of that on there. So if you want to go see how well you did, go look. They're graded, and I posted.
So does that have our final midterm grade?
Yeah, that is your midterm grade. But don't worry about the midterm grade if you didn't do well, or if you did well, then more power to you. I'm not saying who did and who didn't, because I can't. But if you didn't do well, and then there's still hope, right? You still have all of the next, what is it, 4-6 chapters to go, and those go
My
fast.
goodness.
What I usually do is after chapter 2, I turn off the reading. I'm sorry, after chapter 3, or whichever chapters, I don't even remember anymore. Okay, let me see. I don't want to minimize, but I do need to go look at, I do need to go look at that because I'm not sure which chapter it is. Let me go check real quick. Are we still? Oh yeah, we're still open. Okay, good. All right, let me go there. Yeah, exit. Yeah, it's too long.
So I didn't click on the chapter 2 quiz and connect, but is we ready for it now?
Yes. Oh yes.
Okay.
It is
Okay.
ready, and it's already set for you to take. And I already gave you the extensions.
Okay.
And if you don't have
Thank you.
extensions, let me know, because then I have to set a date. And sometimes it does take it, and sometimes it doesn't. But okay, so it's chapter 7 and 3. Yeah, after chapter 3, I turn off the reading.
Okay.
I don't do readings for this one. Let's see, 8, 5, 4, and 6. Yeah, so it's half and half. So basically, I'm going to turn these off now. Now, see, if you're online, yeah, if you're online, right, then no, I don't turn them off because you need this, because I'm not there. But if you're not online, then yes, I do turn these off because they are not really necessary 100%. You still can do the reading, just don't, they're not a mandatory thing anymore. But chapter 2, 7, and 3, yes, definitely you've got to read those.
2, 7, and 3.
Yeah. So 7 is next, and 7 has the electron configuration, which we were skipping today, which is what we'll look at next. And it also has the electromagnetic spectrum. So do not let me forget about the electromagnetic spectrum, because I will tend to skip it because it's not in my PowerPoint, because it is math. And basically, I just kind of show you some stuff. That's it. It's not a real PowerPoint on there. Okay. All right. So that's basically all we needed today.
Okay. Thank you.
Have a good fall
Yes,
break.
thank you so much.
All of that one whole day.
Yes, thank you.
That cracks me up every time.
Have a good one.
You too. Bye.
Bye-bye.